Hi everybody. In the first lecture of the surface chemistry, we have discussed the basic concept of the adsorption, the difference between the adsorbent and adsorbate, as well as the difference between the adsorption and absorption. In this lecture, we are going to discuss factors affecting on adsorption and types of adsorption. So here the first point is factors affecting on adsorption. So here there are various factors which affect on the phenomenon of the adsorption. So let us consider one by one. So the first factor is the nature and surface area of the adsorbent. In the last lecture already we have discussed what is meant by adsorbent and what is meant by adsorbate. So here when we consider the example of acetic acid and charcoal system, so here in this case the charcoal is the adsorbent while the acetic acid is the adsorbate, or charcoal and sulfur dioxide system. So here charcoal is the adsorbent while the sulfur dioxide it is the adsorbate. So the first factor which affect on the phenomenon of the adsorption is nature and surface area of the adsorbent. So here as adsorption takes place on the surface of substance, hence extent of adsorption is directly proportional to the surface area of the adsorbent for a given mass. So friends, here we know that the adsorption is the surface phenomenon, and the definition of the adsorption is that is a collection of the substance on the surface of the another substance, it is called as the adsorption. So here adsorption it is a surface phenomenon and it is directly proportional to the surface area of the adsorbent for the given mass. So here the extent of the adsorption can be increases by activating the adsorbent and can be achieved by making their surface rough by mechanical rubbing. So here the chemical action and removal of the volatile impurity by heating or other processes. So here the surface area of the adsorbent it makes active by using this technique. So number one is the mechanical rubbing, then chemical action and removal of the volatile impurity by heating or other process. So let us consider the example of the wood charcoal. So here the wood charcoal it is activated by heating the charcoal between the temperature 350 degrees Celsius to 1000 degrees Celsius. Hence here the free surface area made available for the adsorption. Whatever impurities or whatever moisture is present on the surface of the charcoal, that impurity or that moisture it can be removed just by heating the charcoal. In this way here the surface area of the charcoal it makes activated. So here the first factor, that is the nature and the surface area of the adsorbent. Generally here if the more surface area is available for the adsorption, generally the rate of the adsorption is more, and here if the surface area of the adsorbent it is active or it is activated, again here the rate of the adsorption is more. Then the second factor is nature of the gas. The gases which are easily liquefied or the gases which have high critical temperature, and the gases which are highly soluble in the water are adsorbed to the greater extent. So here if the gas has high critical temperature as well as if that gas is highly soluble in the water, then here the rate of the adsorption is more. So here let us consider one example. Here the volume of adsorb of chlorine. So the critical temperature of the chlorine gas it is a 417 Kelvin. So here the volume adsorb of chlorine by 1 gram of charcoal at 15 degrees Celsius it is a 235 ml. That means here 1 gram of the charcoal it adsorb 235 ml of the chlorine gas. So here when we consider the another case, that is the nitrogen. So here the adsorption of nitrogen by the 1 gram of charcoal it is just by 8 ml. That means here the only the 8 ml nitrogen gas is adsorbed by the 1 gram of the charcoal, and here the critical temperature of the nitrogen it is 126 Kelvin. So here when we compare the critical temperature of the chlorine and the nitrogen, so the critical temperature of the chlorine is 417 Kelvin while the nitrogen is 126 Kelvin, and here 230 ml chlorine is adsorbed by the 1 gram of charcoal, while in case of the nitrogen only 8 ml of the nitrogen is adsorbed by the same amount of the charcoal, that is a 1 gram. So, here the second factor is the nature of the gas which affect on the adsorption. Then the third factor is the temperature. So, the extent of the adsorption, it varies inversely with the temperature. That is, here the rate of the adsorption or the extent of the adsorption, it varies inversely with the temperature. That means, here as we increase the temperature, here the extent of adsorption or the rate of the adsorption, it decreases. So, lower the temperature, higher is the adsorption. So, it can be concluded that heat must be liberated during the adsorption, not absorption, adsorption. So, here when the adsorption process takes place, here heat must be liberated. The fourth factor is the pressure. If adsorbate is a gas, then adsorption increases with the pressure of the gas. However, once the active sites are occupied by the gas, the further increase in pressure has little or no effect on amount of the gas adsorbed. So, here the fourth factor is the pressure. So, here if the adsorbate is the gas, then the adsorption increases with the pressure of the gas. That means, here as we increase the pressure, here the rate of the adsorption is also increases. Then here fifth factor is the reversible nature. The equilibrium of adsorption is strongly affected by the temperature. The adsorbed gas can be removed by increase in temperature or by decreasing the pressure. So, whatever gas is adsorbed by the adsorbent, such a gas it can be removed just by increasing the temperature or by decreasing the pressure. And here this removal of the adsorbate from the surface of the adsorbent, it is called as the desorption. So, desorption is the reverse process of the adsorption. So, the fifth factor which affect on the adsorption is the reversible nature. Then here number 6, exothermic nature. So, here adsorption undergoes exothermic process. So, all of you know that exothermic process is a process in which the heat is evolved, and the heat evolved in the adsorption is called as the heat of adsorption. That means, here when the process of the adsorption takes place, heat is evolved, and whatever heat is evolved, that heat it is called as the heat of adsorption. And the last factor is the specific nature. The adsorption of gases by the solid may be selective. So, let us consider one example here from the mixture of the ethylene and coal gas. The charcoal adsorb only the ethylene gas. So, here from the mixture of the ethylene and coal gas, here the charcoal it adsorb only the ethylene. So, here the adsorption of gases by solid, it may be selective. So, these are the 7 factors which affect on the phenomenon of the adsorption. Then let us consider the next point, that is the characteristics of the process of adsorption. So, the first characteristic is it occurs on the surface of the adsorbent. So, all of you know that adsorption is a surface phenomenon. So, here the adsorption always occur on the surface of the adsorbent. Second one is the concentration of the adsorbate is always higher on the surface than in bulk. Once again, here the process of the adsorption is the surface phenomenon, or it is a surface process. So, here the concentration of the adsorbate it is more on the surface than in bulk. Then it involves physical forces or the chemical forces. So, here there are two types of the adsorption, that is a physical adsorption as well as the chemical adsorption, and in these two process the physical force as well as the chemical forces are involved. It takes place with the evolution of the heat. That means, here during the adsorption heat is always evolved, and it is called as the heat of adsorption. So, here adsorption takes place with the evolution of the heat. Depends on the pressure or temperature. The process of the adsorption it always depends on the pressure or temperature. The adsorbed particles form multi-layer on the surface of the adsorbent in physical adsorption and monolayer in chemical adsorption, that is the chemisorption. So, here during the adsorption, if there is a physical adsorption, there is a formation of the multimolecular layer on the surface of the adsorbent. If it is a chemical adsorption or it is a chemisorption, then there is a formation of the monolayer. And lastly, it helps heterogeneous catalysis. So, here these are the characteristics of the phenomenon adsorption. Then the next point, types of adsorption. So, here adsorption can be classified into the two types, namely physical or van der Waals adsorption. So, this physical adsorption it is also called as the van der Waals adsorption. and second one is the chemisorption or activated adsorption. So, let us consider again one by one. So, physical or the van der Waals adsorption. So, here these are the properties of the physical or the van der Waals adsorption. So, number one, in this type of the adsorption, the gas molecules are held on the surface of the adsorbent by weak van der Waals forces. These forces are weak and they are non-specific in nature. So, here this is the first characteristics or the first property of the physical or the van der Waals absorption. So, here second one is the physical adsorption is characterized by the low heat of adsorption of order of 10 kilocalorie or less per molecule of the adsorbate. So, here that is the heat of adsorption for the physical adsorption, it is a low. So, here that means here the physical adsorption it occur at the low temperature. The process of the adsorption is reversible. That means here the physical adsorption is reversible and equilibrium is established rapidly. The process is easily reversed either by rising the temperature or by lowering the pressure. So, here when we consider the physical adsorption, if we increase the temperature in case of the physical adsorption, the process is reversible, or if we decrease the pressure, again here the process of the adsorption is reversible. Then the physical adsorption, the adsorbed layer may be several molecule thick, that is there is a formation of the multimolecular layer. So, on the surface of the adsorbent here during the physical adsorption there is a formation of the multimolecular layer. It may be found in all instances. Example, gases like H2, N2, carbon monoxide, then methane, carbon dioxide, HCl, then H2S, NH3, chlorine, sulfur dioxide, all these gases get adsorbed by the charcoal adsorbent. Though the occurrence of the physical adsorption is non-specific in nature, the extent of the adsorption is specific in nature. So, thus it depends on the nature of the adsorbent and nature of the adsorbate. But here what is important, the physical adsorption it is a non-specific in nature. That means here the any gas may be adsorbed on the surface of the adsorbent. Then example of the physical adsorption, adsorption of the various gases on the charcoal. Then the second type, that is a chemical or activated adsorption or the chemisorption. And here these are the characteristics of the chemical or activated adsorption. In chemical adsorption, gas molecules are held on the surface of the adsorbent by the forces similar to the chemical bond. So, here whatever forces are used in the chemical adsorption, these forces are similar to the chemical bonds. Therefore, the compound may be formed on the surface of the adsorbent. So, one example, in the adsorption of the oxygen on the tungsten. So, here the tungsten it is an adsorbent while oxygen it is an adsorbate. So, here it has been observed that there is a reaction between the oxygen and the tungsten, and there is a formation of the tungsten trioxide on the surface of the adsorbent at about 1200 Kelvin. And here the forces involved in the chemical adsorption are strong and they are highly specific in nature. Then second one is it is characterized by the high heat of adsorption. So, near about 20 to 100 kilocalorie per mole of the adsorbent. That means here it occurs at the high temperature. That means when the chemical adsorption takes place, here the large amount of heat is evolved, and here so that here we can say that the chemical adsorption it occur at the high temperature. Chemical adsorption it is rarely reversible. So, that is desorption is difficult, because here on the surface of the adsorbent there is a formation of the compound between the adsorbate and the adsorbent. So, here chemical adsorption it is rarely reversible. To remove the adsorbed gas, the solid must be heated at high temperature and or it pumped with the help of the high vacuum or with the help of the vacuum pump. Then and then it is reversible, but generally it is rarely reversible. So, here in the chemical adsorption, the adsorption layer is only single molecular thick, that is there is a formation of the monomolecular layer only on the surface of the adsorbent. While in case of the physical adsorption, there is a multimolecular layer, but in case of the chemical adsorption, there is a formation of the monomolecular layer. The chemical adsorption is found only when there is a tendency toward compound formation between the gas and the adsorbent. That means here there is a formation of the compound on the surface of the adsorbent, that is the chemical adsorption takes place if there is a tendency of formation of the compound between the adsorbate and the adsorbent. Example of the chemical adsorption: the adsorption of the carbon monoxide gas on the tungsten, or here the adsorption of the oxygen gas on the silver, gold or platinum, or adsorption of the hydrogen on the nickel. So, here the hydrogen is chemisorbed on the nickel. So, hydrogen molecule is first adsorbed by the van der Waals forces and then dissociate. So, here when the hydrogen molecule, when it adsorbs on the surface of the nickel, there is a dissociation of the hydrogen molecule. So, here let us consider this diagram. The hydrogen dissociates before it is chemisorbed on the nickel. So, here first hydrogen molecule, it adsorbs on the surface of the nickel by the physical adsorption, and here then there is a dissociation of the hydrogen gas on the surface of the nickel. So, here these are some example of the chemical adsorption. Lastly, let us consider the difference between the physical adsorption and the chemical adsorption. So, here the first point, the physical adsorption, it occurs due to the weak van der Waals forces, while chemical adsorption or the chemisorption, it occurs due to the chemical reaction on the solid surface and gas is held by the strong chemical bond. The second point is the heat of adsorption is less, about 5 kilocalorie per mole or less than 10 kilocalorie per mole. Here in case of the chemical adsorption, heat of adsorption is large, it is in between 20 to 100 kilocalorie per mole. Then here physical adsorption depend on the nature of the gas. Easily liquefiable gases are adsorbed easily, while the chemical adsorption, it is much more specific in nature. Then here the physical adsorption occurs at low temperature, decreases with increase in temperature, that is the rate of the adsorption decreases with increase in temperature in case of the physical adsorption. Here increases with the increase in temperature. Then here physical adsorption, increases of pressure increases the adsorption, while decreases of the pressure causes the desorption. That means here in case of the physical adsorption, as we increase the pressure, the rate of the physical adsorption is increases. As we decrease the pressure, here the rate of the physical adsorption, it also decreases. Change of pressure has no such effect on the chemical adsorption. Then in physical adsorption, there is a formation of the multimolecular layer on the adsorbent surface, while in case of the chemical adsorption, there is a formation of the unimolecular layer on the surface of the adsorbent. So, these are the some points which distinguish between the physical adsorption and the chemical adsorption. So, here friends, in today's lecture we have discussed the various factors which affect on the phenomenon of the adsorption as well as characteristics of the adsorption, and here the types of the adsorption such as physical adsorption as well as the chemical adsorption, and the difference between the chemical adsorption and the physical adsorption. Thank you.